So yeah, I'm going to start the session now. So yesterday, let me recap quickly what we discussed, right, so that you can catch it up. So we talked about OOPS concepts. So the four OOPS concepts that Java adopted is what you called abstraction, encapsulation, inheritance, and polymorphism, right? So we talked about in a basic way how it is happened. Abstraction is something uh, providing the necessary properties and necessary operations by hiding the internal details. So like I said, you don't need to worry about how the car engine has been designed internally. You just need to know, press the car brake and the car will be, tires will stop rotating and car will be stopped. That's what you need to know. How the functionality has been designed, the outside world should not be worried about. That's how you need to design when you are designing an object. That's what called an abstraction. Another one is encapsulation. So when you're writing, you need to put all together. Properties and the operations that you do should be together in a single entity. That is nothing but an encapsulation. Like I mentioned, the brake and the tires are in the same car. So which means the car is achieving the encapsulation behavior, right? So in Java, how can we achieve encapsulation? By making all the variables private and all the methods in the class is a public. So next is inheritance. Inheritance is nothing but the main core reason for inheritance is making use of what you call making use of code reusability. So code reusability is nothing but um, uh, write once and make use of the functionality from the superclass. So it's like a car design has been there. So when BMW want to bring up a car, and in future if Apple want to get into the car business, all they need to know is they need to adopt what is the car design that has been there already in place, and then start building their own enhancements, like enhancing like driverless car, enhancing battery runs by battery, or else like enhancing by based on the identifying the routes based on the traffic kind of designs they can enhance around the car. So that is nothing but inheritance. You can take the existing behavior, existing design and adopt it. And another one is polymorphism. What is polymorphism? Polymorphism is what one operation, whatever the operation, behaving differently in different situations. So yesterday we took an example, TV remote switch button, switch off and on button, right? So among those, like I said, we'll see what is, there are two types of polymorphism. One is compile time polymorphism, another one runtime polymorphism. So then we talked about object and class. Object is a physical entity from the JVM point of view, which means the object literally loads into the memory. Class is a blueprint. Class is a blueprint or logical entity of a object. So object, if somebody asks what is an object, it's in, you can different ways you can say it's an instance of a class. Okay, it's one of the instance of a class. Like you have a building design, you can build one building. What is this building? Building an object. Whose object is this? The design that has been there for the building, for the design class called building design is the uh, blueprint of that object. Okay, so uh, so how do you write a class? We wrote already a couple of classes, but let's discuss quickly, right? This is the prototype of how to write a class. So you need to have a keyword called class and whatever the variable name that you want to give. So that variable name always need to start with capital letter, and it should start with braces, and corresponding ending braces will be there. Then only it will be considered as a Java class. And when you're saving this class, you need to make this class as a public, because any Java class that you want to referred with the name that you want to save with the name, then you need to make that class as public. Public is what? Another keyword. Okay, we'll see what exactly. See, keywords are with smaller letters, remember. Okay, then inside what we can do, you can write a different type of data type, different type of variables Like what is data types? We talked about it, right? We talked about data types. What are there? Int, float, double, char, and byte. What else is there? Let's go back. Boolean. Byte, short, int, long, float, double, char, boolean. These are the data types. What type of data types? Here I didn't mention the type of the kind of data type, but this data type is nothing but a primitive data type. We call it as primitive data types. We'll see why we differentiate, why we can't simply call these things as data type, because data types have two types of data types. One is primitive data type, another one is what you call reference variable data types. Okay, reference variables kind of thing. We'll discuss, that's not, don't worry. There are two types of variables actually. So you can write whatever the data type that you want, either primitive data type or primitive data type variables, or reference type data type variables as well. Okay, variable names like int. This is data type is int a, b, something like that, or else you can initialize them. Float, boolean, is flag true, is flag false, something like that. And then what else you can write? You can write a methods inside the class. What is the structure? What is the prototype of method is? There should be default return type should be there. Okay, what is the outcome you are going to get by calling that method? Okay, that is the return type. And method name always should start small letter, and you can pass as many inputs as you want. If you want to pass one input, you can pass one input. If you want to pass two inputs, you can pass two inputs. You can pass as many inputs as you want, and then you do whatever the operations you want. Like basically what you do, anything, right? If you want to start the car, right? What is the input for the starting the car? Keys, right? Key is the starting point of this input for the starting the car. Then whatever you want to do with the key, you can write here. Whatever you want to do with the key inside the method, that is the operation that you're going to do. You're going to ignite with the key. You're going to ignite with the key. You're going to ignite the car with the key, right? So what will happen? Car starts running. That is the return type. That is what you're going to get, right? So if you pass the keys for the starting the car, if you pass the keys to the car, and inside method, run method, let's say, if you ignite it, the return what that you're going to get is starting the car. That is the return type. So just think like that. Okay, whatever it takes the input and it applies some operations, it does something on this inputs, it make use of the inputs, then it will return something. Okay, that is called return type. This is the structure. Okay, when you write return type, there are different types, return types. You can write return an int. You can return nothing. When you are returning nothing, you call it as void. When you are returning true or false, then you can call it as return type as boolean. When you when you are returning some double, you can return type as double. Okay, then that is the structure of the class. So we talked about objects, right? So another part is object. So like I said, object is the physical entity, and instance of the class. Object is a physical entity and instance of a class. Okay, so how do we create an object? So we know that we talked about it's a blueprint, blah blah blah, and the object is a physical entity, blah blah blah. So how do you create, right? That is the core important point. So how do you create? Creating the object class name is class name, syntax class name, and then object name, whatever the name that you want to give, and new is the keyword, and again class name with braces. This is called a constructor. If you write something with the brackets immediately to the class name, then it is called a constructor. Okay, so for example, here you can see there is a class called Belinfo. Then Belinfo is the class name and B is the, you can call it as object name or reference variable of Belinfo. And the new is the keyword that you use to create a Belinfo object. And in order to create a Belinfo, this is the constructor that is going to trigger. That is the logic. So if you look at here, first thing, declaration is this is the declaration. Okay, the core set in bold are all variables declarations that associated variable name with object type. Okay, instantiation is the new keyword is the Java operator that creates the object. So whenever you want to create an object, you need to use the for now, remember. Okay, new is the keyword. Okay, initialization, what is the initialization? Whatever the result of this, you are going to assign it to this variable. Okay, initialization is the new operator is followed by a call to the constructor. This is the constructor. See, what is the difference between constructor and class name? Class name doesn't have brackets, constructor is going to have brackets. Okay, which initializes the new object. Okay, so this is what, if you look at, if there is a design called class, you can have a BMW car as an object 1 and Audi car as object 2, Tesla car as an object 3. All are derived from the design of the class. Make sense? So that is what it is. So let's do simple program. I mean, yesterday we did. Let's do another program. I think not required. We did good program yesterday. So let's not put too much energy here. So car is the class name, and we said the structure of the class is it should start with class, and any class that you want to save the class name with the same, save the class Java class with the same class name, then it should be public class. Why? Because you can write as many classes as you want in a single file. Okay, rule number 1, you can write as many classes as you want. This is one class. You can write another class here from here, like, you know, class BMW car, BMW, another class. You can write it as long as it is not public. So in entire single file, entire single Java file, you should have only one public class, and all remaining should be default or some other private or default or protected. I'll tell you what is the protected, what is the, if you don't mention anything, that is considered as default. If you mention private, it is considered as private. If you mention protected, it's protected, it is considered as protected. What are these variables is like nothing but they are scoped variables. Those keywords will help you to scope the class, scope the variables, wherever you use. If you use next to the class, it will scope the class. It will give the scope to the class. If you use the same private, protected, public, default to the variables, class variables, then the scope of the variable will be defined. If you use the same variables to a method, this is the structure of the method, we talked about it, right? So we kept it public, so which means this method can be accessible anywhere. That is the scope. So we'll see what is, when you use, what will happen. We'll do some example, but this is what, like this is the fourth keyword. So for any file that you want to save, simple rule that whatever the name that you want to save, here we want to save the file name as car.java, so that car class should be public. You can write as many classes as you want inside, but other classes should be non-public. Okay, so we wrote the class name, that is good. And so this is the data type, and these are the variables that we defined. This is the methods that we returned. So how do we created an object around this car? This is the car demo we used to run the programs. You need to have this public static void main. Any program, if you want to start, it starts with public static void main strings. So you created a car object. This is how you created a car object. Okay, when you create a car object, constructor will be get called by default. Default constructor will be called, and then you provided some inputs to this. you designed the car, like you called it as the car that you are going to design is Audi car. You are not designing a Audi cycle. Okay, remember, you are designing still Audi car because you are taking the characteristics of the car, and then you started adding the behavior of the Audi car, the characteristics of the Audi car. Audi car max gears is 3, increment number of seats is 5, and the car name is Audi car. Then it will become a Audi car. That is what your definition. So in real time, Audi car will have some other definition. So what is the definition that you provide is going to be decide the object behavior. Okay, this car you designed as a Tesla car, and number of seats is 4 and max gates is 5, and you call it as a Tesla, and it may have some symbol, right? So that is how they design the car. And then when you decide, you ask for displaying the car details, it will display what. If it is Audi car, it will display Audi car designs. If it is Tesla, if it displays Tesla car details. So that is the another concept. We looked at it. Then yeah, so there are different type of variables. I just told you, right? Java comes with the following different type of variables. What and all the variables? We know what is variable, right? So this is the variable. If you see, this is the variable, this is the variable, this is the variable, this is the variable. Here we have how many variables? 4 variables. Okay, good. Here how many variables we have? Can anyone able to guess? We have 2 variables. What are those? Audi car, Tesla. These are the 2 variables. What is this? This is an object, right? Yes. This is the reference variable. Audi car here is a reference variable holding the car behavior, holding the Audi car behavior. You got my point? So this is the highlighted part is the one that object will be created. That object will be referred to Audi car. Okay. So let me see if I have some design, a small diagram or something, so that let me give me a second. Give me a second, I just kind of got it. See here, right? Mm, yeah, we can see this one. See here, if you can able to see the S1, you just focus on this top portion, you can get to know easily this top portion, whatever I'm talking about. S1 is nothing but our, let's assume our Audi car. This is the reference variable. This is the reference variable of type car. Remember, okay? This is the reference variable. There are two types of variables I told: primitive variable, reference variable. This is the reference variable of type car. So if you observe here, let's assume S1 is nothing but a car, Audi car, the highlighted one, okay? So whatever the remaining part, the student and the variables inside, string, Georgia, demo, dom, int, all this part is an object. So this is holding the address of this entire object. What is the address? Bytecodes, right? The starting point of the student object will be kept inside the reference variable. So when somebody want to refer this one, they will refer the address and then try to get from the address to the name, the last name, the scores, all the stuff. Here also this Audi car holding the details of the Audi car, and if somebody want to access max guess, they can access through Audi car dot something, because this is the one which knows the address of this highlighted part. Okay, that is how we call it as reference variable. Okay, this is the reference variable. Okay, so this is how you create the car object. Okay, how do you create an object in the class in Java? Using the new keyword. Okay, so this is the Audi car is the reference variable of car, and new is the keyword to instantiation for the car object, and car constructor will be used to trigger the object, create the object, and once you create it and you are assigning that address to the Audi car. So if somebody asks what is there inside Audi car, now if somebody asks whatever they know, what will be there inside that particular reference variable, it will have an address. You will have an address of car object. Okay, that is how you need to understand. Next, I should have kept the diagram somewhere. Let me try it next time. So I told you two types of reference variables, right? One is primitive variables, and if it is reference variables. So another one is local variables. Another one is instance variables. Another one is static variable. Another one is final variable. So let me do these two things. What are these two? Local variables and instance variables. What are these? Okay. If you in this class, okay, let's say int a equal to 10. If you write anything outside the methods inside the class, if you write anything inside the class outside the method, this is outside the method but inside the class, that is called instance variable. That is called instance variable or class variable. Instance variable or class variable. Got it? But if you write something here, then it is called local variable. Local variable. So what is the scope of this A variable? What is the scope of this A variable? To what where and all you can access this variable, right? You assigned a variable, where and all you can use it. You can access entire class. You can access this entire class, including inside the method. If you type something like this, right? System dot out dot println A, let's say for time being, just I'll explain what is static, why it is not here. If you access like this, it can be accessible. It can be accessible inside the method as well. Okay, but Can I access this B variable? What is the scope of this? What is B? B is a local variable. Okay, you call it as local variable. What is the scope of local variable? Local variable is within the scope of that particular method. Local variable scope is within the scope of that particular method. Where if you write something, if you define any variable inside the method, it called the local variable, and the local variable scope dies within that. The moment you comes out here, if you come out here, system dot out dot print ln, if you type B, what happened? Seriously. Basically, all I'm trying to say is, yeah, if you type this one, it can't access outside, or it can't access outside at all, right? But if you type A, it can be accessible. A can be accessible across. If you have more than one method, we have how many methods here? We have only one method. If you have another method called, let's say, simply I'm copy pasting. You can call it as some public void test. Okay, you don't need any arguments here, let's say. Okay, see, so what is the scope of B? Scope of the B dies within this method. If you try to access here in test method, you can't access it. You can't access in test method B variable, because the scope dies there. Local variable scope dies in the within the method. But what about the variables that has been declared in the, what about the variables that have been declared outside the method and inside the class? The scope will be across the class. If you have 10 methods in the class, those 10 methods can be, if you have 10 methods inside the class, then those 10 methods can be able to access that class variable. Okay, that is the difference. That is the definition. Okay, so let's see what it's what I mentioned. Primitive variables, a variable declared with primitive data types. Like I said, int, long, double is called primitive variables. Default variables for primitive variables depends on the primitive data type you used, which means if you don't initialize the value here, what is the value for A? As it is int, the default value for int data type is 0. So the initial value will be 0. If in case if I made it as double, the initial value, the default value assigned to A is 0.0. Okay, that is the default value. Memory size for the primitive variable is depends on the primitive type what we use. That's correct, right? We know that because if you look at yeah, what is the default size? What is the size of? If you use int, it takes 4 bytes of the memory. If you use long, it takes 8 bytes of the memory. If you take double, it takes 8 bytes of memory. If you take boolean, it takes 1 bit, 1 or 0 kind of thing. Okay, that is what default memory size. Then reference variables. Variables declared with class type is called reference variable. Variable declared with class type is called reference variable. So in this case, variable declared with class type, car is a class, is called a reference variable. Variable declared with class type is called reference variable. The default value of the reference variable is null. So if somebody, if you type like this, and then Audi car, see up to here, what is the default value here? Is null, because you haven't initialized. Where you initialized, this is just a declaration. This is just a declaration. Up to this line, line number 8, the value of the Audi car is null. The reference variable value is null. But here, the reference variable of the Audi car is new car object. Car object started creating. And by end of this line, the behavior has been given. Gears, increment, seats, car name, everything has been provided to this reference variable. You got my point? That is what called reference variable's default value is null. Okay, and default memory size of a reference variable is 8 bytes. So which means even if you assign as much object as you can assign, but the size of the ADCOR reference variable will be 8 bytes, because that is the maximum address that required. All it needs to hold the address, right? All it needs to hold the address, not the object. All this reference variable is need to hold the ADCOR object beginning address. Okay, so it requires maximum 8 bytes. Then local variables. Variables declared inside the method is called local variables. Scope of the local variable within the scope of inside the method is called local variable. Scope of local variable is within the method where it is declared. That's it, right? That's what we talked about just now. If you this is the what is the scope, what is the local variable here? B. What is the scope of B? Within the main method. Within the main method. If I write something like here, double amount. So what double amount? 0.0. Okay. Let's say what is the amount? What is the scope of amount? Within the test method. That's what scope. Okay. If you try to access this amount, double amount outside this method, you cannot access. It will give you an error. You cannot access, it will say. When we initialize local variables explicitly, otherwise following error will come. Variable xyz might not be initialized. Variable xyz might not be initialized. Let's see what happens, right? What I can do, what he's saying is, if you are using a local variable, if you are defining a local variable, you must initialize. There is no default value concept. If you are saying you must initialize. So let's see what value we'll get, right? Let's see if I try to system.out.println displaying B value. Let's see what happens, right? What it is saying? The local variable B may not be initialized. So if you want to access the variable, if you want to define a local variable, it must be initialized. It must be initialized with some value. Okay, but that is not the case for instance variable or class variable. This variable is called, we call it as instance variable or class variable. So that is not the case. If you don't initialize, the default value will be assigned. Okay. What is the next one? Yeah, local variables can be primitive variables or reference variables. I mean, which means this is the local variable. Local variable can be primitive variable. This is the primitive variable or reference variable. You can write reference variables also inside the method. And memory allocated for local variable when you invoke in the method. We will talk about this when we talk about memory diagram. In single diagram I can explain later. JVM allocates the memory for local variables in the stack frame where the definition is stored. Yeah, these two I'll discuss. Instance variable. Variables declared inside the class without static keyword are called as instance variable. So variable declared inside the class, this is inside the class, without static keyword, I don't see any static keyword here, are called as instance variable. So this one falls into this A variable fall into instance variable category. Okay. Another one is instance variables, no need to initialize. Yeah, we haven't initialized, it's still working for us. So initialize instance variable, no need to initialize. When you are not initializing instance variables, JVM will initialize them with the default value. That's what we discussed. Scope of the instance variables are within the class where it is declared. Scope of the instance variable is within the class where it is declared. Instance variables can be primitive variables or reference variable. Okay. this JVM allocates memory for instance variable when you are creating an object. JVM allocates memory for instance variable in the heap. Okay, that is something we will discuss when we talk about variables. So another two variables that is left is static variables and final variables. This is something we need to understand. So before going into static, let's go to the final. Did I mention anywhere in the final? Yeah. Final variables are nothing but a variable declared with final modifier are called as final variables. So we have final keyword, right? If I type this one, then this variable is called a final variable. This variable is called a final variable, but it is still giving an error because the moment you use final, which means the value is going to be fixed. The value is going to be constant across the application, across the programs, across the JVM. You can't change the value. Okay, so for example, if this is how it is, right? Now I mentioned a equal to 10 here. Here I can do this here because that is static and unnecessary confuses you guys. Let me copy here this top portion. I'm copying it here so that you can see together. Okay, so if I type so a value is 10 inside test method. If I try to a equal to 30 and then if I type a and if I try to access this method here, the value will be displayed will be 30, the new variable. So the variable a value has been changed from here 10 to 30. Okay, you can change it, but as soon as you made it as final, you can see error here. What it is saying, the final field car demo.a cannot be assigned. You cannot add a different value. You cannot provide a new initialization because you declared this a variable when you are declaring this class variable as final. So you cannot change. Okay, that is what variable declared with the final modifier is called final variable. So you cannot change. When the moment you kept the value, you must initialize that variable. Generally, class variables you need not to initialize. Only method variables or local variables you need to initialize. But here the final variable, when the moment you make a class variable or local variable, if you make it as a final, then that variable must be initialized. Okay, so let's say if I don't do this, okay, see what error you see. What is error? If you go there and see, the blank final field may not have been initialized. So which means you must initialize. The moment you see, either you can initialize or remove the final keyword. It depends on the what's requirement you have. Okay, that is what final. You can use final keyword in for the class variables as well as method variables or local variables. So this variable is called class variable or instance variable. This variable is called method variable or local variable. Okay, this variable is called local variable or method variable or else local reference variable, method reference variable, right? Cool. Final variables is allowed for instance variables, static variables and local variables. Okay, so you can apply either this final keyword can be applied to local variables, can be applied to class variables. That's what they're saying. Okay, nice. So let's go back to static. That is, what is the static keyword? What happens when I use static? Static is something interesting you need to see. Static is a modifier in Java, modifier keyword in Java, which can be used for various methods and for classes various methods and for classes. which means you can apply to static for methods. So that is what we do for the first point. You remember public static void main. So static keyword we will apply. What happens with that? I'll tell you. And static modifier members with static keyword. So this is the members with static keyword called static member, static keyword. So if this main is the static member, if I keep static here, this variable is static variable. This no longer class variable. The moment you use apply static, this no longer class variable. This is the static variable. Just don't get confused. Just see the words, like, you know, it's just here and there. You need to understand when to use static, when to use final. This is all just to give you overview. Static, when to use static, when to you apply final, when to apply public, when to apply protected. So all you need to learning all the keywords that has been there, what is the use of them, how to use them, when to use them, what is the purpose of what is the impact of using them. That's what we are learning. Okay, so static variables are declared with a static keyword. For example, static int a. What happens is only one copy of memory will be allocated for static variable. For all the objects, all objects will share the same memory location, which means this one also I'll show it to you. Static variable Java memory. See here, did he explain properly? So here, right, we just see, let's see simple way of explaining, right? The diagrammatically, I thought you guys can easily understand. Even if I talk 10 to 20 minutes, it's a little bit confusing to you guys. So basically here what we have, there is a object called student with roll number, marks, name and college name. What is having a class name called student with roll number, marks, name and college name. So when he created a student one, okay, when he created a student one with the ABCD name with marks this one and 100, when he created this student, he didn't created a college name. Let's assume he defined the college name as static. Let's see, somewhere he defined, yeah, static. He defined the college name as static. So what happens is it doesn't come along with the object. It doesn't create the static keyword, doesn't whenever you use static keyword, let's listen carefully. Whenever you use static keyword, then that loads along with the class, not along with the object creation. When the class loads, When the class loads, the static keywords, the static variables will be loaded along with the class. Now, generally, all the variables, right? All the variables. When these variables will be loaded into the memory along with the object creation of the car. Along with the object creation of the car. When you write this line, all the variables loaded into memory. All these variables loaded into memory. But the moment you say static, let's say, so now what and all loads with memory? Gear, boolean, batteries, battery, engine, car name, but number of seats doesn't load. When this will load? Before that, before object creation, static variables will be loaded. Static will be loaded along with the class loading, not object creation. Okay, that's the reason the class college name has been separately. So which means both students carry the same college, goes to the same college. You don't need to create the college name again and again. Whenever you create each student object, you don't need to create the college object, college name, right? Whenever you create a student object, you need to create a new roll number for sure, because you can't give the same roll number to the two students. You need to have different marks because each one has different performance. You need to have different name because each one carries different name. But if they are going to the same college, or else if you are building an application for the same college, then the college name can be same for all the students. Then make that variable as static, so that you don't need to create that college name for each and every object. Rather than that, it will load and will be shared across the object. When you create a static variable, it will be load along with the, remember, I'm repeating again, when you make any variable static, when you make any variable as a static variable, then that static variable will be loaded along with the class loader, along with the class loader, and it will be available across all the objects that has been created. Okay, so another way, that static variable will be shared across all the objects. That static variable will be shared across the objects. Okay, so that is what it happened here. Okay, so where is that? Yeah, only one copy of memory will be allocated static variable for all the objects. All the objects will share the same memory location. Memory allocated for the static variables when JVM loading the class into the memory, not when JVM loading the class into the memory, not while creating the object from the class. Remember, okay? Memory is allocated for the static variables when JVM first loads the class, and it will look for any static variables inside the class. If there is any static variables, it will start initializing with those static variables and create a memory location, and then looks for the continuation of does he creating any objects corresponding to this class. If he is creating any objects corresponding to the loaded class, you will start creating the objects as per the instructions given by the developer, and then start assigning the static variable to each and every object that you create. If you create a 10 students objects, it will create a 10 students objects, and it will share this college name across all the 10 students. That is the purpose of static variable. So where and all you can use static for methods, you can use static for variables, class variables. Okay, you cannot use static for the local variables. What are local variables? Local variables are nothing but method variables. Static variables belong to a class, so we can call it as so we can call static variables with the class name directly. That is something I can tell you quickly. So basically what happens if you want to if you want to access this gear variable, right here, from here, let me clear out this shit. So let's see, this one also not required. Okay, this is the main demo that we are going to run against the car object, right? Okay, so How do I create a car object? Car, some new car equal to new car. Okay. So I created a empty car, no new, whatever the default values that has been there, gears are 0 default value, and the car that I created just now is having gears are 0, number of seats is default 4, his battery engine is default value is false, string name is empty. Right? If I try to access, right, new car dot, I can access the car name. You see, I can access the car name, right? I can give some variable. I can say here Audi car. This is not the way you're supposed to do, but I'm just showing how you can access. Okay, you need to always access the properties members. Always access the members of the class through methods. Okay, but I'm just showing. So new car gear equal to into variable 5. So you can access any variable. You can access any variable inside the class with the object name, with the object, right? So you can access new car. What is the static variable that defined? Number of seat, right? So let me try to see number of seats. See, you can access static variable. You can access as many times even as using the object reference variable. Using the object reference variable, you cannot access the variables of that class, but this variable, this static variable, can be accessed with the class name also. Now you access through the class object. You can access through the class name as well, because the static variable loaded with the class along with the class. So car dot, see, you will see only number of seats. You can say 8, something like that. I'm just trying to show you. So what is the difference? Here you are trying to access this variable with the class name, because this variable is static and it is loaded along with the class into the memory. So it can be accessed through class or it can be accessed through object. Okay, you got my point. So let's say new car equal to, sorry, new another car, right? Another car, not to confuse you. Okay, don't get confused also. I'm just trying to cover a lot of scenarios here. New car, let's see, for now this one, and now I'm going to call another car dot gear equal to 10. Nice. Another car dot, let me change number of seats equal to 10. Okay, so another car number of seats is 10, gear is 10, and the new car gear is 5, number of seats is 6. So let me try to display it here. System dot out dot new car details. Just focus for a couple of minutes. Okay, I'll finish. Now I want to display new car number of seats, and let me, before that I want to display new car gear. Okay, and copy pasting for another car. Okay, I'll just change. Now let's see what happens, so what is the expected output? This is 5, this is 6, and this one should be supposed to be 10, this one supposed to be 10. Let's see, not to confuse, so let's give 5 for new car both, and 10 for other car. Okay, let me run this program. What happened? What we expected, both for new car, both gear and number of seats should be written 5 5, and another car both should be written 10 10. But it is something, so for another car we expected whatever we expected, we got it. But new car, what happened? 5 defined for gear, okay, but something wrong with the 10. Why it displayed 10 instead of 5? So this variable is static. Okay, so which means it will be shared across. This number of seats is a static variable. This doesn't load along with object creation. It loads along with class. When your class is loading, these variables will be loaded. So if you assign a new variable, if you assign a new value, then a single place here, observe, right? If this guy, let's say initially it's a IIT, then somebody is called triple IT. Then if somebody try to override with triple IT, then everybody can be going to get it as triple IT, because it is shared across. It is shared across. If you modified, it will be affected across all objects. If you change a static variable, then it will reflect all the objects that are using that static variable. Make sense? That is what called static variable. And you can use static variable for what? Methods as well, static methods. So difference is, methods defined with static keyword are called static methods. Methods defined with static keyword are called static methods. Method defined with static variable are called static variables. Static method is called static method. And static method belongs to class. Just like static variable belongs to class, static methods also belong to class. We can invoke static methods by class name, just like the static variables that we can invoke with the class name. Same thing we can do with static methods as well. You can invoke through class name or object of the class. Inside the static method, we can use static variables and static methods. We cannot use non-static variables and non-static methods directly. So which means I'll do the program tomorrow, don't worry. Let's finish this last line. Inside non-static methods, we can use static members, non-static members. So basically, right, what he's trying to say is, so what I'm trying to say in that method is, if you have a static method here, and if I try to write another method, let's say, okay, public void non-static method, okay, non-static method, yes, so I am non-static. So what it's trying to say is, public, let's say another one, let's not touch the main method, so you don't need to get confused. Static, all I'm doing is static. I'm just, for the new convenience part, I'll just naming them this static method like that. So non-static, I am non-static method. I am static method, sorry. So what is trying to say, inside the static method we can use static variables, static methods. So inside the static methods we can use static variables and static methods. Let's see, I'll define int a equal to 20, and another one is static int b equal to 30. So ideally the scope of variable with at class level, right? These two are outside the method, so it's a class variable. So when I try to access a here, a equal to 30 I'll give, okay, b equal to 50, let's say. Can I able to access? So what does it mean? I can it doesn't matter. You can access static and non-static variables. You can access static and non-static variables inside a non-static method. Getting my point? You can access static and non-static variables inside a non-static method. Let's try to access this guy. This is the static method, right? We use the static keyword. So this is the static method. So can I able to access this guy? Let's see. Good. I didn't get any error. So inside a non-static method, you can even access static method. So for non-static methods, there is no rules. So no need to confuse. For non-static methods, static variables, non-static variables, non-static methods, static methods, anything can be accessed. Rule comes for, hello? You guys there? Can anyone confirm me? How about now? Okay, that's good. Okay, cool. Um, I'm just scared, like I can't repeat all the stuff, right? Yeah. So no restrictions for non-static methods. But what about the static methods? When you use static keyword, it becomes a static method. Let me try to use static variable first. Okay, let me try to change the static variable. So no error, you don't see error, right? So you can able to access static variables inside the static method. Awesome. Let me try accessing a. You get the error. What is the error? Cannot make a static reference to the non-static field a. So which means non-static variables cannot be accessed inside static methods inside static methods directly. Remember, non-static variables and non-static methods, which means non-static method, non-static variable cannot be accessed inside the static method directly. This is direct access. This is called direct access. This is called direct access. Directly cannot be accessed. How can we access? We can able to access this non-static member variables through creating an object, corresponding object. What is the corresponding object? Car demo. So all you need to do is, in order to access this non-static method here, let's say non-static, sorry, and a equal to 50. You cannot access these two. These two gives you error. How can we access? In order to access these two guys, first you need to create corresponding object car demo equal to new car demo something. You can give something car D, nothing, anything you can give. It should start small letter, and then you can access car D dot A equal to 60. So in order to access A, first you can access through reference variable, object variable. You cannot access directly. This is what it means. In order to access non-static variable, here also car D dot non-static. So this line is allowed. This line is not allowed. You got my point? So non-static variables inside the static method can be accessed only through by creating an object. They cannot be accessed through directly. Okay, so that's all about for today. Tomorrow I'm not taking the class. Some guests are coming, so day after tomorrow I'll take the class. But my humble request is go back and read all these six variables. Try to understand. I'm not asking you to learn just like that, but my request is, in order to avoid all the confusions, in order to keep the concept strong in your mind, go back immediately and read Java documentation. You can read. There are a bunch of people who are writing um, concepts on the online, right? So you just go and read. You can look at my documentation that I wrote. You can look at my site that I mentioned. So try to understand as much as you guys can. Yeah, I'm not expecting you guys to understand 100%, but the moment you type programs, the more comfortable you get all these things. Okay, so let's catch up on Wednesday then, and we'll see, like, what we can do for the I'll send you for the next class details. Okay, thanks guys.